Good morning. My goal in this talk is not only to convince you that natural gas is not the villain in global warming, but is the savior, but also to try to give you the arguments you need to convince others of this fact. When I began the Berkeley Earth Project 4 years ago, in collaboration with my daughter, in my mind, the skeptics had raised some very valid points. In fact, I would argue that even today, skeptics are right on almost everything that they say. Hurricanes are not increasing. Variability is not increasing. I've been looking at this scientifically. The number of tornadoes has been going down. The variability in temperature is not increasing. People love to ascribe changes in weather to the most recent villain. But if you look at it scientifically, that's not really the case. On the other hand, global warming is real, and it's caused by humans. This was the conclusion that we reached after 4 years of intensive study in which we reanalyzed over 1 billion data points and used the most advanced statistical methods. This is not what my talk is about, so let me just quickly summarize. This is our published plot. And what it shows, if you look on it, is the temperature variability over the last 250 years. And in that time, you can see volcanic eruptions very clearly. And those are identified volcanic eruptions. If we look at the solar variability, it doesn't match at all. We can rule, because we can go back so far, we can rule out the solar variability. The curve you see here is not an exponential. That doesn't fit so well. It's not a curve of the population. That doesn't fit so well. It's the carbon dioxide level. That's the best fit that we obtained. Global warming is real, and it's caused by carbon dioxide increases in the atmosphere. Here's a list of the things that I say skeptics are right on. So respect the skeptics. They're only wrong on one thing, and that's when they say global warming isn't real and it isn't caused by humans. On everything else, the reason we have so many skeptics is because there's so much exaggeration out there. And again, that's not the topic of my talk, but I wanted to start by assuring you that I am so concerned about global warming now, because I know it's caused by carbon dioxide increases, and I know most of that comes from humans, and I know that's going to continue. And so I'm concerned about this. Will it be bad? I'm not sure, but it will be different, and different is usually bad. If I asked you, is it okay if I mutate one of your genes? Hey, maybe it'll be good for you. Now, different is usually bad. What's going to happen in the future? Well, this is what's happened in the past. Take a look at this. This is the United States. This doesn't have BC in it. I realize BC has been bouncing around a little bit, but look at the emissions from China. Emissions from China have shot up because their economy is developing and because they're depending mostly on coal. Meanwhile, the United States has gone down. Part of the decrease in the US has been because of the economy slowing, but more than that came from a switch from coal to natural gas. The biggest reason the US is going down in emissions is because of a switch from coal to natural gas, largely because it's cheaper. Not because we are idealists who want to stop global warming, but it's coming about because of the economy. And my belief is that if we can depend on the economy, if we can facilitate the economics of it, that we can stop global warming. And personally, I'm committed to stopping global warming. But if you're going to stop global warming, you have to think globally. Now, ironically, many people say, think globally, work locally. Yes, but when they work locally, they forget their global thoughts. If you ever hear 3 or 4 minutes on global warming and China isn't mentioned, then you're not really hearing about global warming. Because, unfortunately, China is now emitting twice as much as the US. And predictions are, the developed nations are no longer in command. You can do things here in BC to be green, and that'll make you feel good. But unless we address China, we are not addressing the problem. You are addressing China here in BC, because among the truly important things that can be done to address global warming, much more so than reducing emissions from pipes, much more so than being green and having grass on the roof of your convention center, much more important than all of that is to get natural gas to China. for the environment for two reasons I'll come to. One of them is global warming. This is one of the big things. In the big things in this world, to stop global warming, there are two that are giant. One of them is energy conservation. And this is huge because we waste money, and because we waste money, it's economically viable, it's profitable to use energy conservation. And I can go through a long list of this. You can find them in my books. I wrote Energy for Future Presidents. This is all detailed there. You really make money through energy conservation. Why don't we do it? Because not every investment is something that happens naturally, even in a free market economy. And if you can facilitate that, people will make the investments. They will make money while reducing the carbon emissions. But the other thing is a switch from coal to natural gas. That's the most important thing we can do. This is a plot that appeared in an op-ed piece I wrote in the Wall Street Journal several years ago, showing what would happen if we signed all the treaties, in this case the Copenhagen Treaty, and ask what happened. And you can see that if we signed the Copenhagen Treaty, the US emissions would go down, the Kyoto developed states, which include Canada, all that would go down too, but the emerging economies would continue to go up because according to the Kyoto Treaty, they were allowed to grow their carbon emissions as their economy grows. And I think anybody who wishes to see the developed world become developed, the undeveloped world become developed, has to agree to this. So this is the problem. It is good for China to increase its energy use. It's good for India, for Malaysia. It's good to increase the energy use from my point of view. But how do we do this without global warming? That's the trick. If you look at these projections, if the treaty had been, the strong treaty, had been signed and abided by, the emissions in the coming years would be totally dominated by the developing world. I mean, in Berkeley, my class asked me, what kind of car do I drive? I say, a Prius. And they applaud me. And then I criticize them. I say, you think me buying a Prius does some good. It doesn't, because me buying a Prius doesn't set an example that the developing world can afford to follow. So you shouldn't cheer me for being green. It's a meaningless green unless you're setting an example that makes economic sense in the developing world. Now, as you know, there's a huge amount of shale gas. This is an incredible revolution. Almost everybody in this room knows that. I speak to a lot of groups that require being told that. This is a plot of various countries. Canada is here. Here's the US. The red are the oil supplies we have. This does not include the new shale oil, but this does include the oil sands. But what you see is that in the old story, here's Saudi Arabia totally dominating. But now with the shale gas, and by the way, I believe the levels of shale gas in the US are much larger than these official numbers. And this comes not from idle speculation, but from talking with the real experts in the field, which are the experts in the field. These are the people who go out and find shale gas. And I work with them, and they have been right consistently in the past when the numbers had to be increased. But you see, we're all Saudi Arabias now. Now, a little bit of physics, chemistry. When you burn carbon, the main constituent of coal, you make 3 of those to make 3 carbon dioxides. For the same energy of 3 carbons, you burn 1 methane molecule. What's really going on is that methane has this hydrogen. And so when you burn it, you're making water. And water, even though it's a greenhouse gas, we don't control the level of water in the atmosphere. The reason is because we have oceans and rivers and ice everywhere. And so you add water to the atmosphere, it doesn't change the water in the atmosphere. It will be determined mostly by the temperature, actually. But the fact is, natural gas produces 1/3 of the carbon dioxide for the same energy out. That's amazing, and it's the key to seeing why the transition to natural gas is so important. And the simple way to say it is natural gas, you're burning not just the carbon, you're also burning the hydrogen. CH4, those hydrogens give you a lot of the energy. Okay, people who oppose natural gas oppose it for a whole host of reasons. One of which I don't mention here, but we'll talk about later, and that is they oppose it because they fear that it is so cheap, it will put renewables out of business. And I think that, I'll talk more about that later. But these are the issues: flaming faucets, deplete fresh water, pollution of aquifers, earthquakes, fugitive methane, air pollution. These are the arguments I come up against, which I have looked at carefully and reached the remarkable conclusion that none of these are as difficult to solve as the simplest problems in solar, wind, the other so-called renewables. That these problems, yeah, there are problems, but from a technological, engineering, physics point of view, the problems to solve in these are really easy. Actually, not all of them are problems. This is if you haven't seen this, you don't understand why there is opposition to natural gas. I'm going to play a little segment. This is actually excerpted from a movie called Gasland, which every one of you should watch. Because if you don't watch that, you don't understand why there is opposition. I've been to meetings in Berkeley where people come in and say, you know, Josh Fox, I almost worship him because he changed my life by giving me this thing I can do now, oppose natural gas. You've got to understand the religious fervor that you get, which derives largely from Josh Fox and Gasland. So let's watch a little segment that was taken from Gasland and used as an anti-natural gas segment. Okay.
Okay.
That's Josh Fox. Oh, this is, wait a minute, this is, wait a second. I'm sorry, that was the wrong one. Let's do this one.
Just give it a second. Whoa.
Do you understand what natural gas is doing to your tap water? If this is all you saw, you probably are guessing that fracking is causing flaming faucets. They don't actually say that, but that's probably what you'd guess. It's been studied. There's no disputing the matter that fracking is not causing flaming faucets. This has been studied because you can measure the methane from these flaming faucets, and you could identify the difference between biogenic methane, which comes from bacteria in the soil, and from methane that's coming from deep natural gas, which, for example, has no carbon-14 in it, because it's been buried for millions of years. So you can tell the difference. And the methane of these flaming faucets is not coming from fracking. But the public doesn't know this. Fortunately, there's another movie that recently came out called Frack Nation, in which it was sort of the gotcha journalism. And there's Josh Fox, who created this. And a journalist gets up and says, so, Mr. Fox, flaming faucets existed long before fracking. Why don't you show that in your movie? And here's his answer.
Okay.
There's a report from 1976.
Well, I don't care about the report from 1976. There were reports from 1936 that people say they could light their water on fire in New York State.
No, I'm curious about why you didn't include relevant reports from 1976 or 1936 in the documentary. Most people watching your film would think that lighting your water started with fracking. You've said yourself, people lit their water long before fracking started. Isn't that correct?
Well, yes, but it's not relevant.
So this is a movie called Frack Nation. And it has an astonishing effect on the true believers. They are stunned to find this out and shocked. People are easily fooled, but they don't like to be told that they were fooled. And when they learn that, they sometimes react in the opposite way. We're seeing this in the United States now, where many people are objecting to doing anything about global warming. Now, I wrote a column 12 years ago in which I predicted this might happen because of the exaggerations of global warming, because everybody's saying every time there's a local storm that I don't like, that's global warming. Be prepared for more Hurricane Katrinas. Be prepared for more Sandys. Nonsense. Those have nothing to do with global warming. But when you say that, and people believe it, and they act on it, and then nothing happens, then they feel that they've been tricked, and they overreact. And I think much of the lack of support in the United States does not come because of the success of the skeptics. It comes about because the skeptics were right on so many things. Yet global warming is real, and I'm devoting my life to stopping it now. So, flaming faucets, false issue. Depleting fresh water, fascinating issue. Okay, Apache. I'm a big fan of Apache. I know Apache is deeply involved here in BC in the Horn River Formation. This is one of the largest plays in the world. And they developed it entirely without using any fresh water. In fact, more recently in the Permian Basin, they are developing that, and they use half of their water was saline water. I talked to my friends in Texas, and they said, well, the real problem is the companies don't want to use fresh water. We want them to, because we can charge them for the water that they use, and we get more money from that than we do from agriculture. Fresh water, Vic Rao, who was the former CTO at Halliburton, he believes fresh water should not be used in fracking anymore. There is no need to use fresh water. You can use brines. Well, where do you get the brines? Let me show you a map of China, because that's a particular interest of mine, because China is the biggest producer of carbon dioxide in the world today, and if we're going to address global warming, we have to address China. So here is China. On the left is a map of the shale gas regions, and on the right, the blue areas are the brines. Now, it looks kind of coincidental. Why is every place you see shale, they say in the Tarim Basin there's no fresh water, so they can't develop their shale gas. Instead, they're going to import it from Russia. But look at all the brines available there. The reason it has to do with geology. When you have these formations in which you develop shale gas, you have formations which also collect deep water. You go 100 meters down, you have fresh water. You go 500 meters down, you have brine. It's been down there a long time. It's gotten salty. It has no commercial value other than carbon capture and sequestration. Think of putting it in the deep brines. That's how I have this map, because it's been mapped for the purpose of CCS. And there are brines essentially everywhere. Fresh water, it should not be an issue. And this is because you never have to use it. So, pollution of aquifers. Oh, let me show this movie. This is actually, how am I doing on time? I'm doing okay. Okay, so this is the way you frack. And some people may not be familiar with the details. You get past the fresh water. Then you pull out the drilling pipe, and you put down the casing, steel pipe. Then you fill out with cement, which goes up on the outside and makes a barrier. You can have several layers of this. Basically, the idea is to isolate it. If industry best practice is used, there's no pollution. The problem is industry best practice is not always used. We need to regulate it and insist that industry best practice is done. Now look how far down it goes. This is something people don't appreciate. Getting all the way down to the shale layer. Then you're the kickoff point, you begin your horizontal drilling. But this is 2 kilometers down. The fresh water is 100 meters down. This is far from the fresh water. Then you pull out the drilling pipe, and you put in the casing. Again, cement. The cement goes through the pipe and comes out the outside to cement it, then water. So now you have the cement on the outside. Now you put down the fracking gun, perforation gun, excuse me. At this point, the tower goes away. You're no longer drilling, you don't need the big tower. And you put down the perf gun. So it goes down, and it sets off explosives that go through and break not only the casing, but the cement and a little bit of the rock. Boom. I said, boom. Thank you. They pull that out, push down, pull it out, put down water and sand mixture. These chemicals are now being disclosed by most companies in the United States, and they should be disclosed by everybody. But polluting the ground is not really an issue. The ground is polluted. It's full of hydrocarbons and other things. That causes the fractures. The sand hold the fractures open. It's a completely false issue that you're polluting the ground. This is full of carcinogens. The ground is full of carcinogens. Now, once you've done that, and you've fracked this area, then you put in a plug. And typically we'll come in with the fracking gun, the perforation gun, perforate again. The fracking is actually when you pump in the water and it goes in, and this is called the second stage. You can have up to 20 stages these days, and you can have many, many pumps from the same stage. Then you either remove those or you drill them open, and now you have the gas flowing, and it can flow. Initially, you get most of your payback in the first 2 years. If you don't make a profit in the first 2 years, you're not going to make a profit. But gas continues to flow for 20, 30 years. That's what we believe. And you could refrac it. There are many things that you can do. Okay. So, do we get earthquakes from this? It's way too far down and too little. You're talking here about 10 to 50 meters of fracking buried 2 kilometers down. You can't feel that on the surface. These are Richter 1 earthquakes. But you do get earthquakes when that water comes up and you dispose of it improperly in storage wells. And this is where the major earthquakes have come about, not from the fracking itself, but from pumping the water into storage formations that have faults in them. It's been poorly done. That can be regulated. There should never be more earthquakes with a minimal amount of regulation. Okay, fugitive methane. And also recycling of the water, of course. Now, when the water comes back out, you send it down another frac well. You could use something like 90% of it that way. So fugitive methane, people say fugitive methane in the atmosphere has a global warming potential 33 times bigger than that of CO2, which is true. Then people say, therefore, we can't even let 3% leak. That's wrong. That's a mental calculation in which they ignored several very important factors. One of them is that this factor of 33 is not actually the ratio of global warming potential of 1 molecule of CH4 to 1 molecule of CO2. It's for equal weights, which means almost 3 molecules of methane for 1 molecule of CO2. It's for equal weights. That's just historically the way they did it. What that means is that the molecule per molecule global warming potential is only a factor of 12. Well, that's still a big factor. But it means you can have a lot more leakage than just a few percent. In fact, the number turns out to be that you could have 13% leakage and still have an advantage over coal. Of course, you don't want 13% leakage. You're throwing away 13% of your profits. But the numbers, there's a discussion taking place in the literature in which all these facts are known. I'm not saying anything that disagrees with even the Howarth position on this. He agrees with all this. You can even find these numbers in his appendix. But the way the numbers are taken out of context is they say even if only a few percent leaks, then the negation, the advantage over coal is gone. That is simply not true. We have memos on our Berkeley Earth site that go through this in detail. We're writing another memo now. There's a lot to be said about this. It's one of the things that we're doing is talking about the fugitive methane issue, but it is not accurately perceived by the public. The Howarth article claimed that up to 6% is leaking. And he was wrong on that. But even 6% doesn't negate the big advantage that natural gas has over coal. That's what we have to recognize. People say it has to be less than 1%. Not for global warming purposes. I mean, you want it to be less than 1% so you don't throw away money. But for global warming, 1% is fine, 2% is fine. The contribution to global warming, you don't want it to be 2%, but you don't have to legislate it to be under 1%. That's making it, then you're spending a lot of money in the wrong place. Here's another thing that came about. This is from a paper by Alvarez, recently getting a lot of attention. The key point here, and this was also true in a recent paper by Brandt. Brandt got a lot of attention in the newspapers. People said, Brandt has shown you can't have leakage. And it talks about all the bad things. But if you look at Brandt's paper, it's actually quite reasonable. And we're writing a memo that will be online probably within a week on our berkeleyearth.org website. And what he shows, among other things, this is from, is that most sites have very little leakage, very, very little. But there are a few super sites that have enormous leakage, enormous. And they're the ones that contribute to the large levels of fugitive methane. What this means is that to attack the fugitive methane problem, don't legislate that everybody has to reduce their leakage by 33%. That would not do anything. What you have to do is to say everybody should get their leakage down to a few percent. Get rid of these super leakers, and you will get rid of the larger numbers that people are publishing. Not that those larger numbers are large enough to negate the value over coal. And the nice thing is these super leakers are super interested in reducing their leakage because they're the ones who can make the most money. If you have a 10% leakage rate, then it's worth spending a lot of money reducing that down to 1%. So fugitive methane is not an issue. air pollution. So, photo I took in Beijing sunrise. This is air pollution in China yesterday. You can get this on the web every day. What does red mean? Red means unhealthy air. Purple means very unhealthy, and there are a few hazardous sites. India is also bad. There are fewer sites being monitored in India. I certainly hope that will change. My sense is whenever I look at this map, India is worse than Beijing. Air pollution is a very, very serious problem. How serious? According to very thoughtful, reasonable, and undisputed surveys, China deaths, I could talk to you about this in detail if you'd give me another half hour. China deaths are 1.2 million per year from air pollution. Those numbers are solid. And it's being ignored by environmental agencies in the West. It's the biggest environmental issue in the world today, even bigger than global warming. Global warming is off in the future, and it's bad. But this is killing 1 million people per year, and it's going to get worse as the air pollution in China increases. Estimates are 75,000 die every year in the US. That's like twice the number that die from automobile accidents, getting very little attention for various reasons. 400,000 in Europe. These are the 1.2 million in China is the most solid of all these numbers, and 2 million in the rest of the developing world. What can you do about it? Look at the emissions. These air pollution comes mostly from particulates. And if you look at 7 versus 2,700, burning natural gas reduces the most significant part of the air pollution by a factor of 400. The most important thing we can do to help to reduce the greatest environmental problem in the world today is to ship LNG to China. No, there's something else you could do. You could help them with their energy conservation measures. One of our speakers today is addressing that from the Environmental Defense Fund. They are in Beijing. That is their primary interest. It is the biggest. It's the 800-pound gorilla in China. More efficient use of energy. But there's a 700-pound gorilla that has switched them from coal to natural gas. And Russia is helping, but you guys can help too. What do I have here? Let me skip this because I'm a little bit low on time. But the key thing here is that China needs to reduce its air pollution. For that reason, they need to switch to natural gas. That is, in my mind, the primary reason for them to switch. We get the benefit if we help them switch, that it reduces their growth of greenhouse emissions very significantly, and we get the benefit of that. So this is what I call acting, thinking globally. Being green and putting grass on the roof of your building makes you feel good. But if you can reduce the use of coal in China, you are actually addressing global warming in a way that nobody else is. Not at Kyoto, not at Copenhagen. These treaties, much more important than that, is to get China off coal onto natural gas, which they want to do. And right now, they need to import it, and they're trying to develop it. That's important. So here's an article I read with my daughter, why every serious environmentalist should favor fracking. I'm going to wind up with a little humorous note, if you will forgive me, on this very serious topic. People say we should save the polar bears. And there's this picture of a polar bear on retreating ice. And, okay, that's fine, save the polar bears. But this is where the pandas live in China. And look at the air pollution there. I'd say let's save the pandas. And just to show you how close I am to the pandas, I'm going to wind up with a little little movie here, 30-second movie. I said, now watch the panda's hand. Watch what he does with his hand. He puts it on my knee. So, anyway, okay. So, understanding the role that natural gas plays and could play, I think it plays a role now. It's largely responsible for the reduction in the United States emissions, and that's a wonderful thing. And I think getting China, and I think LNG, can play as big a role, if not bigger, than the recent agreement between Russia and China. This is our paper. I hope what I've done is not only convince you that natural gas is not a villain, but a savior, but also given you material, and I can send you these few graphs. Go to our Berkeley Earth website, you'll find much of this material. that not only are you convinced, I hope, it's not a villain, but it's actually a savior. It's not just neutral, it's actually a savior. It's what we need. But I hope I've given you the material so you can convince others of this, because this is how we can slow global warming to the point where instead of it becoming really bad in 30, 40 years, it'll become really bad in 60 to 80 years. That gives enough time for us to develop truly inexpensive solar, truly good energy storage for the intermittency problem, good power lines for the wind, and all the other things that we'll be talking about in the innovation panel coming up after this one. So thank you very much.